Okay, so let's quickly try to build the language for model interpretation so that it's easier for everyone, every non technical person to digest and execute. Okay, we start by defining what goes into the model. The raw data that contains all the information about the case, including its journey, its inherent nature, the steps it took, the process that it followed, all that depicts the basic representation of data, say decided by whoever designed the process. Then what? You have an ML model with you through which you want to find out if any of those inherent characteristics of these cases have any idea about the dat or not. To do that, what we have to convert this raw representation into a model friendly representation, and that is done by feature creation. And when you want to enhance this representation of data such that the predictive signal becomes more prominent, you do feature engineering. So feature engineering is that representation of data which increases the density of the predictive or classification predictive signal. When this data goes into the model tries to learn something. I People call it the underlying structure, the underlying mechanism, or trying to learn the real world process, or trying to approximate the real world process conditioned on not conditioned, trying to approximate the underlying process, or tries to learn the underlying part of process which is responsible for driving that. That's it. Then we test its learning by giving it some data and verifying its prediction. So we then give it some data and verify the predictions. If our model is able to perform well on both train and test data, we call that model a good one with good generalization, meaning that it's not like it has just learned the training data as it is. It has actually discovered the mechanism that is present in testing data as well. Yes, and then we try to uncover all and then we uncover all different outputs generated by the model which are relevant for us, which includes what data it used to convey that these are the following columns which are highly predictive of that, or these are the features which are highly predictive in classifying whether a dart will take less than X number of days or more than X number of days. And we try to uncover what rules the model has learned. For example, that a case had a property 1 and a property 2, and therefore its stat will likely be greater than 51, or feature 3 took value XYZ and feature 4 took value DEF, and therefore the cases that follow these rules most likely belong to the higher TAT bucket. And so what I am trying to do is what I'm trying to do is, provided the model has gen has learned well, what are the rules it has created, what are the rules it has created which helped it classify that, we and it's relevant to us because we can also say that, or we can also showcase that following properties to following values together led to this stat bucket or that stat bucket, and therefore if your goal is to find out why certain cases go into the higher stat bucket, you look at the rules and you call them your insight, because that's it. That's pretty much all that you can get from that model. And it should, and it makes business sense. If somebody said that, hey, the country involved being Qatar and the use purpose of data is DEF, and data categories con- when when individual and worker data categories were demanded for transfer, then we have seen that it most likely results in higher debt. And then the rephrasing comes, which will translate into something that is very executive friendly, which are less in numbers and which are directly or indirectly actionable. Because it's far more um, good for us that we are able to correctly use language which increases our reputation to the stakeholders, because now they would believe that these guys know how to actually produce insights and not just numbers, which I don't frankly care about. So that's it, and yeah, I'll end this stream